Hello, everybody. This is Miss Schaefer. I wanted to share with you some practice questions and go through some information for Unit 2. The first thing you want to consider is how much time did you spend studying for this test? Include, time you reviewed the notes or worked on keeping notes and some of your Class Connect session, if you were fully paying attention and really participating, then that is part of your study habits. And so that should count. So think about that. How much time did you spend preparing for this assessment? Part of the reason we want to look at that is our goal is to get 70% or better. Now, of course, you can set your own personal goals, and I hope you all have done that, where you've set your goal for each unit test. And honestly, I hope it's above 70% because I think you should all be able to get to 70% because we have the retake option. So, 85, 80%. 75%, those are all good numbers. 90%, 95%, that's all possible too. You set the goal of what you think you would like to be able to do. And remember that the items that are in the assessment project category have a stronger weight on them. So you might want to redo those whenever you can to help you out. And know that there are a lot of resources available to you on the toolkit links for testing. So here's a couple examples of the word wall, which has vocab review, has pictures, and it has some videos in there. You also have Quizlet, which has some activities. You can create flashcards, but over here you could play some matching games, and there's also some testing in there that you could use to help you out. So think about that and think about these ideas as you're studying or preparing to help you use your time efficiently. And then where do you need to improve so you develop the skills that you need as an adult to always succeed? So go ahead and place this on pause and look at this and check off which ones you have done to help you use your time well. Then also make a list. Give yourself some room to improve. Say, okay, this is what I did, and that's great. And this is what I'm going to do for this next unit to help ensure that I grow even more. Because each time we're progressing, and we want to give ourselves credit for the work we've done, and then also challenge ourselves to improve a little bit. So this review will go back and use some of the study guide ideas to help us reinforce our learning. So you really want to make sure you know the vocabulary and understand how to use it. Anytime you need to pause, please do so. What is the equation for calculating acceleration? Remember, a key part of this is that acceleration is caused by velocity, and velocity is one of the forces. When we're looking at these symbols here on the board, this delta, that's called a delta, the triangle, means change. So we're looking for the rate. Acceleration is the rate of change in the direction of an object. An object changes its speed by 5 meters per second every second. What does this statement describe? Two key words here: changes and meters per second every second. Or in other words, meters per second, or meters per second squared. All of those are the same way of saying the units needed for acceleration. Lots of clues there to help you figure out. And these are test taking skills that we're trying to develop to help us logically work through ideas. An object moves forward at 30 meters per second. What does this statement describe? This one might be a little bit trickier. Notice the word forward. Forward is a direction. So this is direction plus speed. An object travels 300 meters in 10 seconds. What does this statement describe? Notice in this one, no direction is given. We don't know if it's forwards, backwards, up, down, or sideways. That's a key indicator for which choice could or should be made. Piper rides her bike moving 5 meters per second west. What does this statement describe? Put this on pause to answer these questions. What is inertia? How is inertia related to mass? What is required for an object to move? Does this apply in space too? So remember that inertia is an object's resistance to changing its motion. The heavier the object is, the more inertia it will have. By adding a force, which is by definition a push or a pull, it is required to move any object. This applies to objects in space. What will happen to a spacecraft that is in deep space if given a push? You'll want to pause to make sure you have this information well. If you're confused about any of these, please make sure to review the help recordings. Okay, so you're going to apply Newton's first law. Which situations on the board apply to the first law of motion? There are several choices. A, F equals ma. B, a soccer ball is sitting on the grass. C, air is let out of a balloon quickly and the balloon moves around the room. D, it's easier to toss a ping pong ball than a volleyball. E, a cannon shoots out. A cannon, that should read, a cannonball shoots out of a cannon and you see the cannon bounce back. F, a bowling ball is sitting on a table. So which of these situations would be the first law of motion? Which of these situations would be the second law of motion? Which of these situations would be the third law of motion? All right, so we did the lab mass and motion. So let's think about that. When you noticed your data, what happened when velocity increased? Did the momentum increase or decrease as you moved and changed the release point? So think about those. Remember what momentum is versus inertia. Momentum is kind of like inertia in motion. So answer this question. An object with high momentum will be easy to change directions. True or false? Some key vocabulary, you really want to focus on this and remember that gravity is a force, and it's a force that depends on what? Where do objects fall faster, on the moon or the earth? What keeps what keeps the earth in orbit around the sun? Thinking about our net forces lab, where we use different masses to influence the direction that the block would move. More than one force can change the direction depending on its mass and its location. So which direction will this block move? Think about the why. What would you need to balance this force out so that it would not move? Which mass will have the most effect? Which direction will this object accelerate toward? Two situations. First, a box experiences a 20 Newton force to the left and two different 5 Newton forces to the right. Figure out the math. Second situation. A bottle rocket experiences a 500 Newton force to the right and a 300 Newton force of air resistance to the left. All right, so hopefully this has helped you prepare to retaking the Unit 2 assessment. If you have any questions, please let us know. Study, 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 and good luck. I know your effort will pay off.